After these things had been documented, notice not by the company, but by a user, the machine was declared defective. The company eventually issued software patches and hardware updates, which allowed the machine to return to service. The lawsuits were settled out of court, so you can't necessarily see the files. It seemed like the problems were solved, and the next year, another patient was overdosed in Yakima, Washington. This problem was a new one, a counter overflow synchronization error. If the operator sent a command at the exact moment the counter overflowed, the machine would skip setting up some of the beam accessories, including moving the stainless steel aiming mirror. This once again resulted in an unscanned beam and an overdose. That patient died 3 months later. It's important to note that when the company was first told about the issue, they said it is impossible that our machine did this. Somehow the operator must have messed up. I remember when I was a junior programmer, maybe had 3 years experience. I was sitting in my office one day and got a phone call from someone I had worked with on a project. The person said, "Hey, my computer," he meant my computer because I'd written the code, "my computer's doing this behavior. Is it possible that it's from your program, or is it the operating system or something else?" And I replied, "I am 100% certain it cannot be my program." Then I hung up the phone. I did not go back to what I was working on. I sat at my desk thinking, 100% certain? 100% certain? I don't think I can be 100% certain. So I got out my program and I worked very hard to see if it could in fact reproduce the results that the person told me about. And sure enough, it was my code. And I didn't think my code was even influenced by that. So what you have here are some temporal timing issues that were never tested because they tested to the spec and only the spec. And they didn't try testing other things. These days, such things can be automated, and you can literally repeat the experiment a bazillion times with almost everything at different synchronization intervals to make sure that all combinations work. The software was what caused the errors. But this article argues that wasn't the root cause. The entire system design, according to them, was the real problem because the safety critical loads were placed upon software that was not designed to control them. What they mean is the software didn't have any safety specs. It didn't have any tasks that had been QA'd, quality assured, for that type of hardware control. Timing analysis wasn't part of even the thinking at the time. Unit testing never happened. This is the fault of the company. We were definitely unit testing back then. Fault trees for both hardware and software were not created. These tasks are the responsibility of the software engineers and the system engineers. System engineers have to say, I need A, B, and C tested, and software engineers have to write the tests and do the system design. The machine is long gone, but thanks to all the work that was done on why it caused problems, its history continues. This machine was used and studied very carefully to show how badly things can go wrong when you have software life-critical systems that are not properly designed. It is the case that when I went into computer science, in general, we did not write software life-critical devices. Your generation is different. You will be writing devices, or you may be writing devices that will cause people to lose their lives if things happen incorrectly. In this situation, we currently have an awfully lot of software safety practices that will come in and help you do that. I never wanted ever to be responsible for someone's life. I'm lucky I did this job 30 years ago, or I might not have gone into software engineering at all. Doctors save people's lives. And when they make a mistake, they can cost people their lives. I don't know if I already told you this or not. I cannot remember. I do pick up hitchhikers sometimes. Not hitchhikers. I sometimes stop and help people on the side of the road, but only under limited conditions. And one of them is when I see that they're running out of gas and coasting to a halt, and I know that they just ran out of gas. And it's pretty hard to tell, easy to tell a car that's just run out of gas. So if a car's run out of gas and I see it pull over, I will usually stop if I have time and help. Yeah, because I told you guys a couple weeks ago about the problem in New Orleans. This time I did stop, and the driver of the car was a resident. He was a resident for cardiac surgery, and he had been working in an emergency room where his knowledge was ignored, and the reigning doctor, the presiding doctor, I think is the better word, made the wrong decisions, and he was in part responsible for ending someone's life. The man was devastated. I never want to be there. I never want to be responsible for someone's life. But if you are working on safety critical systems, it is very, very important that you pay careful attention to all of the standards and that you question them. Just because they're standards doesn't mean that they're right. And I want to take you down. After this article, there was a bunch of comments, and I want to discuss a couple of the comments. So here, people are arguing that engineers don't make mistakes. So one guy says even real engineers make mistakes. Take a look at the fact that the engineers removed the hardware interlocks. The old system had safety defects, and the safety guidance, safety protection features, and the engineers removed them because they thought the software system was going to work. So yes, engineers make mistakes. Come down here to an argument which I don't want you guys ever to make. It says, no, real engineers don't make mistakes in safety interlocks. That is why safety interlocks are such clunky, dumb things. You can be very sure they work as expected, i.e. within the limits of known materials science. Real engineers can make fail-safe equipment. Then he says he's not an engineer, but he knows some who can do this. Now, I want you to read this sentence right here. Real engineers can make fail-safe equipment. Don't ever believe such a sentence. Don't believe it in software. Don't believe it in hardware. I'm going to go down to another comment and tell you my exact experience with that hardware and how the fail-safe stuff failed me. Someone is going to give an example of another safety feature that overrides a microcontroller, and it suggests it's in your kitchen. It says a microwave generator has safety interlocks on the door so that the microwaves are turned off no matter what happens when the door is opened. The microcontroller can and does turn the beam off. I was in my kitchen, and we didn't get hit by lightning. I have no idea what happened, but my microwave oven door blew open. It exploded. There was an explosion in my microwave. It was a pretty new microwave, to about a month. My microwave oven exploded. The door blew open. the microwave was still going, and then the plug burnt out. So the sequence of events was the explosion, the door flies open, things are still trying to go on, they're very confused, and then the machine fries my plug. I still haven't replaced that kitchen plug. It's been years. So in this case, because the actual safety devices exploded, they were not present to stop the microwave when the door opened. In fact, the door opened very fast. So don't even believe the hardware things will work under every circumstance. Always be a skeptic. Always try to think of something else that you might be able to figure out how to do better. Don't just accept the fact that hardware always works and is a good backup, or the software systems that you have designed are going to work okay. They don't work okay sometimes under odd circumstances. I returned, that was a Panasonic, I returned it to the manufacturer with this information. They did not believe me. If I hadn't been in the kitchen, I wouldn't have been able to tell them the sequence of events. But I was in a very similar circumstance, only this was the hardware interlocks that didn't work. I sent them the sequence of events. I sent them pictures of everything that I had, and they simply didn't believe me. Very frustrating. So don't be that kind of an engineer. If something happens, remember that it's possible you didn't test for it. And I'm pretty sure Panasonic did not test for whatever exploding in my microwave.